Well, good evening, ladies and gentlemen. Welcome to round two of Master Haymaker. Tonight we have Dr. Chris Teutsch, and he's going to be talking to us about making high quality hay and haylage. We also, if he's going to touch on haylage, we're going to deep dive into baleage, haylage at the last session. So he's just going to give us a little taste of what haylage is going to be about. Dr. Chris Teutsch, I am going to turn it over to you, my friend.
Okay, thank you, Philip, and I'd like to thank you guys for inviting me to talk at your Master Haymaker program this evening. It's certainly a pleasure to be with you. I thought I'd just start out and give you a little bit of my background. I grew up on a small crop and livestock farm in Northeast Ohio. After high school, I spent 4 years in the military, and then I spent a year studying agriculture in Europe. Came back and finished a bachelor's and master's in forages at Ohio State University. And then I came to the University of Kentucky where I completed a PhD in forage management. And I actually did my research in southeastern Kentucky looking at stocking rates for reclaimed mine land for beef cattle. So it's truly a pleasure to be with you tonight. Following my PhD, I worked 17 years at Virginia Tech University before coming back to Western Kentucky, and where I'm the forage extension specialist at the Grain and Forage Center of Excellence in Princeton. So I'm all the way on the other side of the state from you all, but it's certainly a pleasure to be here. I'm going to talk about making high quality hay and haylage tonight. I always like to start out when we talk about making high quality hay and haylage by asking what forage quality is. And there's lots of different ways to define that. We can talk about total digestible nutrients or crude protein or dry matter digestibility or relative feed value or relative forage quality. Lots of different ways to define that, but really the essence of what forage quality is the ability of a forage to produce a desired animal response. If I'm milking cows, it's going to be how much milk I can put in the bulk tank. If I have a cow-calf operation, it's going to be keeping condition on those animals and weaning a good calf. If I'm in a stocker operation, it's going to be putting pounds of gain on those animals. That's going to be the real measure of forage quality. All these other measures are trying to get at that single animal performance. I'd like to tell you, just share with you 2 slides on a presentation I did this winter at the Kentucky Cattlemen Association. And I'll refer you, if you look at the bottom here, there's a couple links and you can watch the entire presentation, actually the entire symposium, all the presentations on hay quality, improving hay quality in Kentucky that were presented at the Kentucky Cattlemen Association annual meeting this year. I want to share just a couple slides on hay quality in Kentucky, a historical perspective with you. So we can just get an idea of where we're at in terms of making good quality hay in Kentucky. Real quick on the sample set. So the sample set that I analyzed and presented for the Kentucky Cattlemen Association meeting was a set from Kim Field at the Kentucky Department of Agriculture. She shared over 14,000 samples that were hay samples that were taken from 2007 to 2017. Number of different hays, and the hays were all self-described. So that means that when researchers submitted a sample, they said, well, it's grass clover or alfalfa or small grain or whatever it was. Sometimes those descriptions are really good. Sometimes they're not perfect. The first thing I did with this big data set was I went through and I looked for outliers in the set. So things that didn't quite look right, and we deleted those from the data set before we did the analysis. And then I grouped the samples into the following categories, and I combined a few of the Kentucky Department of Agriculture categories to make it a little more concise. And we predicted total digestible nutrients. That's a measure of energy in that hay using a Virginia Tech equation. I did not use the Kentucky Department of Agricultural equation to predict energy because it tends to predict a little bit lower than I think the true value is. So Virginia Tech is more of a middle of the road equation for predicting energy. And then we calculated all the summary statistics of sample number, minimum, maximum, average, median, standard deviation. If you're interested in seeing all those, watch the full length presentation. I'm going to cut right to the chase in the next slide and talk about the quality of the samples in relation to meeting the nutrient requirements of different animal classes. So one thing that I think is important to mention here is that this sample set is likely skewed towards better quality hay samples. And that's not a fault of the Kentucky Department of Agriculture, but whenever you get a sample set from a forage quality lab, whether it's commercial or university, it's going to have samples in it from people that care enough about their hay to actually test it. And so that's going to be those people that are really trying to do a good job with their hay testing program, with their hay program. So that's going to skew that sample set towards the better quality samples. The worst quality samples are going to be those samples that people never test. People that never submit a sample are going to have worse quality hay, and that's not going to be represented within this data set. So it'll be a little bit skewed towards the high end of hay quality. So this is one of the final slides from the presentation was given to KCA, and it looks at grass and grass clover samples and their ability to meet the energy requirements of various beef cattle classes. So if we look here at the bottom, this first one, we have a dry cow in mid-gestation. That's when her nutrient requirements or her energy requirements are going to be the lowest. So about 80% of the hay samples submitted out of those 14,000 samples are going to meet her requirements. So if we look at a late gestation, so that's when the energy requirement of that animal starting to tick up. The fetus is growing rapidly and it's getting larger. She's getting ready to calf and to start lactation. The energy requirements going up. About 40% of the total samples in this data set would meet her energy requirements. This is when the samples really start to fall apart, is when she starts to lactate. So when that cow calves and she's lactating, she's at peak energy requirement. Only 12% of the samples in this data set would meet her requirements. That's not great news for a cow-calf state. So these requirements are the minimum requirements for keeping condition on that animal. So if I'm feeding a hay that does not meet her requirements when she's lactating, that means she's losing condition. And we all know that condition is very closely related to reproductive efficiency in these animals. So understanding the quality of the hay that you have is very important so that you can supplement it properly during important stages of the production cycle for beef cattle in Kentucky. The last group I want to point out is those animals that are growing. And the point that I want to make here is that most of the hay that we're making, the average quality hay, is not going to meet the nutritional requirements of a growing animal. So they're going to need supplementation. So it's important to know what the quality of that hay is, but it's also important to supplement it to meet the expected average daily gain or your goal of average daily gain. All right, so the question is what's the most important factor impacting forage quality? Is it species? Is it whether you have clover or grass in your stand? Is it fertilization? Is it whether we have weeds in the stand or not? These are all important factors, but what's most important, the single most important factor in where you can make the biggest difference in your hay quality is stage of maturity at harvest. By cutting at the right stage of maturity at harvest, we're going to improve forage quality of the hay that we make. It's the single most important factor impacting forage quality. And this is the effect of growth stage on forage composition. So if we look at the percentage of leaves, as we go from a vegetative stage to a reproductive stage or full bloom, the percentage of leaves as the total biomass decreases and the percentage of stems increase. Generally speaking, stems are going to be much less digestible than leaves. And the protein decreases, the minerals decrease, the fiber and the amount of lignin tends to increase as that plant matures. So the higher level of fiber and the higher amount of lignin, lignin's a compound that makes fiber less digestible in the rumen of the animal, the lower the digestibility of this forage is going to be. And if we look at the effective growth stage on digestibility and yield, we'll see as we go from a leafy vegetative stage to a reproductive stage, we tend to increase our yield. But as we make that same transition, we tend to decrease digestibility and we decrease dry matter intake. So the forage is less digestible and the animals can eat less of that forage. And that's going to limit the amount of nutrients that they can consume in their diet. So where do we need to be? Generally speaking, the best compromise between forage quality, between yield and quality is going to be right here in the middle, kind of at the late boot to early head stage. It's going to give you a decent yield, not the best, but a decent yield, but you're going to have a pretty good forage quality too. If I maximize yield here, I'm going to minimize forage quality, and that's really going to hurt animal performance and the ability of that hay to meet the nutrient requirements of an animal, especially as her energy requirements start to ramp up. Okay. So the best compromise is right here. This is actually a piece of pearl millet. This is the late boot. This is actually early head stage. So this is the flag leaf of the plant. As that seed head kind of swells this boot right here, or the sheath of the plant, we call that the late boot stage. As it starts to emerge, that would be the early head stage. This is the ideal compromise between quality and yield for a grass plant. The effective stage of maturity on animal performance can be dramatic. And this is some data, and we can find this in AGR 62, Quality Hay Productions, one of our extension publications. As that plant goes from late boot to viable seed forming in that plant, we see a significant decrease in crude protein, about 14% to about 7.5%. We see that dry matter intake, so the amount of forage that animal could eat goes from 13 pounds down to 8.6 pounds. We see that the digestibility of the forage decreases from 68% to 56%. And again, the most important measure of forage quality is going to be animal performance. So looking at these steers' performance when they're feeding this hay, harvested at the late boot, early bloom, and seed formation or reproductive stage, 1.4, we decrease that performance to 0.42 pounds a day. So we lose a pound of average daily gain per day just by the stage of maturity at harvest. This is a really important table. If you understand this, you understand how critical it is to harvest at the correct growth stage to improve forage quality. So I'm going to talk a little bit about hay preservation and then a little bit about silage preservation. And Dr. Henning will talk in much greater detail about silage preservation of forage. So hay preservation, the basic objective is to dehydrate or reduce the moisture as rapidly as possible in that forage. So we mow that hay and then we want to get it desiccated or dried out as fast as we possibly can. And by doing that, we concentrate the cell solutes, or the sugars and the starches and carbohydrates and minerals in those cells. And by doing that concentration, that's how we're preserving that hay. We can kind of think of it as dehydrating a piece of fruit. So when we take a slice of an orange and we put it in a dehydrator and we dry it out, what we're doing is we're concentrating those sugars in that orange. and it gets to a point where mold can no longer grow within that piece of orange slice. We're doing the same thing with hay. We're concentrating those cell solutes by reducing that moisture, and we want to do this as rapidly as we possibly can. When we think about a standing forage plant, when we cut it, it's not dead. It's still respiring, so it's carrying out respiration. So it's using up sugars and carbohydrates. So we want to reduce that to 40% moisture or lower as fast as we possibly can to stop respiration in that plant. So, and by doing that, we're going to control microbial growth. Mold is going to grow between 25 and 35% moisture. So we want to get that plant dehydrated to less than 20% moisture as fast as we can. And as that mold grows, if we're in this range of 25 to 35%, it's going to consume nutrients. So sugars and carbohydrates, it's going to use as an energy source, and it's going to respire those. And that's going to cause heating in the hay. So heat is produced, and that's what causes heating in wet hay. It's going to leave toxins that can cause respiratory disease in both humans and animals. And there's an important reaction that happens during this process. So as that hay heats up, the sugars and the protein that hay combine in what we call the browning reaction. They kind of caramelize together. And what happens is that even though the protein is still there in that bale, it becomes unavailable to the ruminant livestock. So we have what we call heat damage protein in that hay bale. So even though we can test it and measure it, and it says that I've got crude protein there, it's not available to that animal for use. And then eventually, if it heats up enough, we can actually have spontaneous combustion, which causes hay fires. And we see some hay fires every year in the Commonwealth. So this is just a nice demonstration. This was some cereal rye that was baled up a little bit too moist, and we can see how it got brown in the center of this bale. This is the browning reaction taking place. This is not unpalatable to animals. Animals will eat this. It actually has a sweet, almost like a tobacco type smell to it. And animals will consume that sometimes readily. The problem is that the protein in this hay where the browning reaction occurred is not available for the animal to digest. And if we put wet hay in a barn and stack it in tight, where it's got no air around it especially, and it heats up to a high enough temperature, we can actually have spontaneous combustion in hay fires. And this again occurs when we harvest hay that's above 20% moisture. And if we do that, we definitely want to monitor internal temperature of the bale. So if we've got hay that's above 20% moisture, we do not want to stack it in a barn where airflow is restricted. We want to leave it set out and let it go through that sweat outside and give it plenty of air around it to get rid of that excessive heat as it heats up. So if we're get up to about 150 degrees Fahrenheit, the temperature could go down, but in all likelihood, it's probably going to keep increasing. We want to move hay to allow better air circulation and then recheck in 2 to 3 hours. If we get up to 175 degrees, we're getting in pretty bad shape. And that means that we're not quite there yet, but fire could be imminent. And one of the worst things we can do if we got them stacked in tight in the barn is just start pulling them out. We really need to call our volunteer fire department and let them get out there, because sometimes when we start to pull those bales out, we introduce oxygen into the system, and that can cause spontaneous combustion to occur. And then if we're above 200 degrees Fahrenheit, fire is probably already present, and we need to call the fire department. And we would expect flames to occur when we start to move those bales around. So the take home from this is work hard to get your hay below 20% moisture before baling. So just a little bit about measuring bale temperature. We want to probe bales. If we got them in a big stack, we want to probe them in the middle of the stack where they have the least airflow. And we want to probe the bale to a depth of 18 to 36 inches. And there's different apparatuses to do that. We can make a homemade tube where we just drop a thermometer on a string or a lightweight wire down into that tube and measure that temperature. We can get a digital, not a digital, but a dial thermometer with a long probe on it where we can actually stick it into a bale, or we can get an electronic sensor that we can actually probe into the bale and measure temperature. This particular one measures both temperature and moisture. There's several methods for determining moisture at baling. And the first one I want to just mention is the hand method. And this is probably the least accurate method. It's very crude and it requires experience. It's definitely not perfect. We can twist hay, and if it breaks, it's too dry. If it slowly untwists, it's too wet. If it kind of springs open and fluffs out, it's just right. Very subjective. So not really a way to quantify moisture. It's just kind of get an idea of where it's at. We can kind of do the same thing with silage. So if we have corn silage and we squeeze it up and it stays in a ball, it's too wet. If it falls right apart, it's too dry. And if it falls slowly apart, then it's just right. I sound like the three bears, right? But this is kind of very crude methods for estimating moisture in forage. Probably a better way would be to use a hay probe. And again, this is not a perfect method, but it's better than just trying to estimate it by sight or feel. Hay probes use something called electroconductance, and they give you an instantaneous reading. They can be handheld or they can be baler mounted. They can mount them in the bale chamber, and it will give you an idea of the moisture. But this is not a perfect method. It's going to depend on bale density. So for real dense bales, it can alter or real loose bales that can alter the results that you're getting, because it's actually measuring an electrical signal that's sent out by the probe. You can get something called a windrow attachment. There's a picture of one right here, and that's where you would take hay from windrow, stuff it into a 5-gallon plastic bucket, and then stuff that probe down on top of that hay. And you'll get a reading, but it's certainly not perfect. It's better if you can read it in a bale that's a uniform density. And again, we want to probe 18 to 36 inches in the firm area of the bale, square bales from the end, round bales from the side. And you want to measure several different spots in that bale and get an average reading, and then probe multiple bales in that hay lot. Probably a better tester would be the Koster tester. And this is nothing high tech. It's just a heating element with a fan on it. And you put some forage in this little basket, set it on there, and it blows hot air up through that forage material. It takes anywhere from 25 minutes to an hour, depending on how wet the forage is, to get the sample dried out. And then you measure it after 20 minutes or so, and then get a weight on it, and then measure it for another 5 minutes, get another weight, and you do this until the weight stabilizes. And then you use this formula to calculate dry matter. This is a very accurate method. These are commonly used in dairies where dry matter intake is extremely important. So understanding how much moisture is in a total mixed ration is very important so that we don't underfeed dairy cows. But we can certainly use those when we're making baleage or hay to estimate forage quality. Probably an equally good method would be the microwave method. Everybody has a microwave. It's got high accuracy, as high as a Koster tester, maybe even a little bit better. It takes about 20 minutes. And what we do is we take that fresh sample, we measure it on a small scale, record the weight, microwave for 3 minutes, reweigh it, microwave for additional 2 minutes and reweigh, and we repeat until the weight doesn't change. And then we use that same formula to calculate the moisture concentration in that forage. And an important tip is that when we're microwaving, that we put a cup of water in there with it, a fresh cup each time we take it out to measure. And that keeps from damaging the microwave. As that forage dries out, we can actually damage the microwave because there's nothing to absorb the heat, and that cup of water will absorb the energy. That cup of water will help to absorb that energy. Okay, let's talk a little bit about hay preservatives and kind of where they fit into forage programs at. And the goal of using a hay preservative is to speed up harvest. It's not a panacea, it's not some kind of a miracle thing, but it can allow you to harvest forage a little bit faster than if you weren't using it. There's two categories. There's drying agents and inhibitors. Drying agents are not commonly used, but they can be used. Potassium carbonate would be the most common one, and it would be most effective on first cutting grass or legumes. And what it does is the potassium carbonates help strip the cuticle of the stem of the plant, allowing moisture to escape at a greater rate. Microbial inhibitors are much more commonly used. And both are applied as a spray, and therefore it's essential that you get uniform coverage, and that means investing in an applicator system. And you can see an applicator system on this small square bale. What's happening here is that it actually sprays that propionic acid on the windrow as it enters the bale chamber. That's the best way to do it because you're getting a more uniform application of that propionic acid. And on this particular setup here, you'll see in a second, we've got a pinwheel moisture, a pinwheel that estimates moisture in that hay through electroconductance. Not perfect, but better than nothing. And that's tied together with an automatic applicator that can actually be programmed to apply propionic acid when the hay surpasses a certain benchmark in moisture content. So let's talk a little bit about microbial inhibitors. The most popular one, and the one that we know works consistently, is propionic acid. And we want to use a buffered propionic acid. And there's a number of different trade names it's marketed under. New Holland has one, John Deere has one, and so forth. Most of them are manufactured by a company called Harvest Tech. And a lot of them will include a little bit of acetic acid, which supposedly helps the forage retain its green color. The idea is that both buffered propionic acid will inhibit microbial growth in that bale, allowing us to harvest that hay at a slightly higher moisture than ideal. It will preserve hay somewhere in that range of 20 to 30% moisture. 30 is pushing it a little bit, but definitely in that 20, 24, 25% moisture range, it can definitely be a benefit at inhibiting microbial growth in that hay. So these are different application rates, and what I want you to notice is not necessarily the particular rate, but as the moisture increases, you need to increase the amount you're applying. So if you're going from 22% moisture up to 30% moisture, we're going to be increasing the amount of propionic acid we apply per ton of hay by about 4 times. So this can get quite costly in many situations. And generally speaking, we never want to bale, even with propionic acid, hay that's over 30% moisture. So when do you use it? And the answer is really when hay's almost dry enough to bale, but not quite, and rain is imminent. If rain's not imminent, there's no reason to use it. Leave it sit out another couple hours, let it cure naturally, and then bale it up. So really the niche for a microbial inhibitor would be right as that hay's almost dry enough and it's going to rain almost for sure. So let's look real quick. We'll summarize best hay management practices. And dry matter losses occur during harvesting primarily with hay and especially with legumes. So things like alfalfa and clovers If we handle those at too high or when they're too dry, we can have a lot of leaf loss in those particular situations. And we can have dry matter losses during hay harvesting of 15 to 30%. So number one, correct growth stage. Remember that first thing that we talked about. We've got to harvest the correct growth stage. It doesn't matter whether you're making baleage or whether you're making hay. If you put a low quality, start with a low quality forage, you're going to have a low quality forage come out at the end. We want to mow early in the day, and that's going to maximize our drying time. And there's some discussion on this, as we move to the Western United States, in a more arid climate, they harvest they cut in the afternoon because that plant has gone through photosynthesis all day, and it tends to have a higher amount of sugars and carbohydrates in it. We don't have that luxury here. We have pretty short windows with no rain, and we need to cut to maximize drying time. So usually early in the day, right after the dew gets off, is the optimum time to mow hay. We want to use a mower conditioner. It's going to crush the stems of the plant and allow moisture to escape and speed up drying. Especially important in first cutting grass crops, summer annuals, and legumes that have a larger stem. We want to make a wide swath. One of the things I often see people doing is putting the wings in on a mower conditioner and putting it in a tight swath. And we don't want to do that. We want it to be as wide as possible coming out the back of that mower. And by doing that, we're exposing that forage to more sunlight. We're going to spread that forage out. It's got more surface area to be heated up and start to lose moisture. It's a simple thing to do, but a lot of people don't do that. We don't want to, we want to rake it at 40 to 50% moisture, and that helps reduce leaf losses. We can ted that hay also at 40 to 50% moisture to spread it out and expose green forage that's below. And then we want to bale at 18 to 20% moisture. We want to be 16 to 18% for large round bales, and we can push it to 18 to 20% for small square bales. The larger the bale, the harder it is for moisture to escape from that bale, especially a densely packed round bale. So we want to make sure that we're in that right moisture range for larger bales. And this is going to reduce leaf loss. It's going to keep the leaves, especially legumes, from getting too dry. They're still going to be pliable, and we'll be able to get them in the bale without losing too many. It's going to inhibit mold growth. Remember, if we're in that 18 to 20% range, we're going to start to slow mold growth down in that bale and reduce heating and the chance of fire in that bale. And then we're going to store that hay under cover to reduce storage losses. And this is especially important if we have a legume hay, which tends not to weather quite as well as a densely packed grass hay bale. All right, let's talk just a little bit about bale silage. And this is probably one of the latest innovations in bale silage. This is a McHale baler. It bales and wraps all in one machine. And the nice part about this is that it minimizes, the way it wraps it minimizes the amount of plastic on the ends of the bale. And it wraps immediately, which is a best management practice for making baleage. So what happens when we make baleage? And so hay is preserved by desiccating that plant and concentrating those solutes. Silage is preserved by making that forage anaerobic and reducing the pH. So the basic objective of baleage or silage preservation is to rapidly reduce that pH. And what we have is lactic acid bacteria, which occur naturally in the environment. When we put those in a situation where there's no oxygen, those lactic acid bacteria, which are anaerobic, means they don't like oxygen, ferment sugars and carbohydrates to acetic acid. And that lowers the pH rapidly. So what's happening here, we bale this up. We have some respiration going on, a little bit of oxygen, and then we start what we call the anaerobic phase. So the oxygen decreases, lactic acid bacteria start to increase, and then they start to go down. And what happens at this point is that the pH or the acidity of that bale is starting to limit bacteria in that bale. And when we finally reach a stable point in the pH of this silage, um, the acidity is actually killing off the lactic acid bacteria. And this forage will be stable until we reintroduce oxygen into this system. And the acid inhibits plant enzymes and microbes that will grow within that forage. And again, silage is stable until we open that system up, whether it's a bale or a silo. We open it back up and introduce oxygen into that system. Let's talk in more detail a little bit about round bale silage, and it's got a lot of advantages. It's a much lower capital investment than building a silage pit or a bunk, and then buying all the equipment to fill that pit or bunk and to feed that silage out. It's generally a higher quality feed than hay preservation. Harvest losses tend to be lower because it's in a moist state when we put it up. Eliminate storage losses compared to hay stored outside. Wrapped bales can be transported if they're individually wrapped. Smaller amounts of forage can be ensiled, and we don't need any special machinery for feeding that silage out. Some disadvantages is that it's not the ideal ensiling package. So it's got a very high surface area to volume ratio compared to a traditional silo. What that means is that there's a lot of places for air to enter into that bale and cause that bale to spoil. Plastic cost is somewhere between $4 and $6 a bale. And then we've got plastic to get rid of also when we feed that out. Longer chop can be harder to ensile, and there's some technological advances where we can actually chop that forage into shorter pieces as it enters that bale chamber, and allows you to make a denser bale. Some balers can't handle high moisture hay. Bales can be heavy, especially if they're baled outside of the ideal range. And if we get holes in the plastic, that can cause those bales to rot or to mold. And then we've got the whole problem of getting rid of the plastic. So not perfect, but it is something that smaller producers can use. So the thing to remember about round bales is that it's not the ideal ensiling package because of that high surface area to volume ratio. There's lots of places that air can get into that ensiling package. So best management practices for round bale silage, and it's no different than anything else. We need to cut at the correct stage of maturity. Ensiling is not some kind of a magical process that takes bad quality forage and makes it good. If you put bad quality forage into a round bale that you're making into bale silage, it's going to be bad quality forage when it comes out. We want to harvest grasses, again, a late boot, legumes at early bloom. Use a mower conditioner to enhance wilting. There's some data that says that it may not speed up wilting as much as we think, at least the initial phase of wilting. And then put it in a wide swath. That's really important to get more of that forage exposed to the sunlight. We can bale at a lower ground speed, which is going to make a denser bale, and then use plastic or untreated sisal twine or net wrap to wrap that. We don't want to use treated sisal twine because it can actually interact with the UV inhibitors in the plastic wrap, causing it to break down over time. Smaller bale, we want to keep bales a little bit smaller to keep the weight manageable. Ideally, we want to wrap bales at the storage site. So if we're wrapping, transporting bales, ideally we'll wrap them at the storage site and then drop them so we don't have to handle them. Every time we touch that bale, there's a chance that we could put a hole in that plastic. So this is just an individual wrapper here. We want to wrap bales ideally immediately, never let them go overnight. So if I'm only make enough bales that I can wrap within one day, the same day. We want to use a good quality wrap designed for silage. It's got to be UV resistance. We want to put on a minimum of 6 layers of wrap. And if we're using a wrapper like pictured above, we want to have a 2x3 system. So that's 50% overlap with 3 revolutions of the bale. And that'll give us 6 layers of plastic on the sides of the bale. If we have to monitor these bales for holes, so if a raccoon or a possum puts a hole in a bale, then we need to patch that immediately. And we can't just patch it with duct tape. We need to use a tape designed for either greenhouse plastic or for baleage that has a UV inhibitor, which will hold up and keep oxygen out. Even small holes in wrapped bales can cause that bale to spoil. And then we want to feed silage the same season. So if I make it this year, I want to feed it out by this time next year. We don't want to try to keep it for 2 or 3 years. Conventional silos are different. They can be kept for a long time because they do a better job at excluding oxygen. Even though we think of plastic wrap as completely impermeable to oxygen, it does have an oxygen permeability. So oxygen will over time permeate through that plastic wrap. I want to take just a minute and mention something that's been happening, and it's something called sweet hay is often referred to. And what sweet hay is hay that's kind of in that in-between place. So hay is good when we have it down below 20% moisture. Silage, ideally, we'd have above 40% moisture. So there's kind of this no man's land between 20 and 40% moisture that neither hay nor silage works perfectly on. What we're finding is the producers are wrapping hay in this kind of this no man's land. And it's almost dry enough for hay, but not almost dry hay, but not quite dry enough. And they wrap it, and it kind of undergoes what we call a partial fermentation. Has kind of a sweet smell to it, but it's certainly not a full fermentation. And some producers are using this as a rain management tool. Some producers are also using it as a weight management tool by letting that hay get drier than that ideal ensiling range. It actually makes these bales quite a bit lighter to handle. So the way that people use this as a rain management tool is that hay's almost dry enough to make as dry hay, but not quite dry enough. So they bale it and then they wrap it, just like you would silage. So we did a study where we actually evaluated moisture content and ensiling on the pH and nutritive value of forage. We ensiled tall fescue all the way from 20% moisture up to 80% moisture. So this is dry enough for hay, and this is the standing plant approximately. So as soon as we cut it, we started to ensile it. And we had a student that worked on this project this last summer, and then in every 4 hours, he would take a sample of that hay until it was ready to bale. And then he would make what we called a mini silo with that forage. So he would take that forage, cut it up into 2 to 3 inch lengths, place it in a food saver bag, and then vacuum seal it. So he would suck the air out of that bag and then seal it up and allow it to ferment. And this is the impact that dry matter and ensiling, if we look at the x-axis here, had on silage pH. So the ideal pH would be somewhere for a grass hay would be around 5 to 5.25. So this is the ideal pH would be right here. Lower is even better, right? But usually we're trying to strive for about 5. So when we look at the ideal ensiling range, so this is dry matter, which would be 35% dry matter to 45% dry matter. Conversely, 55 to 65% moisture. We had good reduction in silage pH. Now, as that forage material dried out and we ensiled it, we did not get full fermentation. That means that this pH was higher. And as we reached the 70 to 80% moisture, we had no more reduction in pH, essentially. So this hay in this moisture range, as we get above this 45% dry matter or 55% moisture, we're not undergoing a full fermentation. Is that bad or good? Well, this was stable until we introduced oxygen back into this system. So this is the impact of dry matter and siling on crude protein. So we saw a decrease as that forage dried out. We saw a decrease, as commonly happens even in dry hay. So if we start out at 8.5 to 9% in dry hay, by the time it dries out, we're going to be around 7.5 to 7% in crude protein. That happens even in dry hay. So this is not really an impact of ensiling, but really an impact of that forage just drying out. We commonly lose 2 to 3% in crude protein as that forage cures as dry hay. We saw very little impact on energy and fiber digestibility by ensiling at higher dry matter concentrations. So what's this data telling us? This data is telling us that if we want to get ideal fermentation, we still need to be in this ideal dry matter range for ensiling. As we get out of that, as long as we can exclude the oxygen, we're not seeing that hay mold, but what's critical is that we exclude that oxygen. So it's very important that we wrap that hay tightly, especially if it's on the drier side of the ideal moisture range. So what our recommendations are right now is that ideally you should be striving for this range of 55 to 65% moisture, or 35 to 45% dry matter. And when you do that, you're going to optimize fermentation of that bale silage. We'll kind of finish things up and just talk a little bit about hay storage. And it drives me crazy to see hay stored like this, sitting outside. We went to the work of baling this up and the cost of baling this up, and then we set it in 3-line and let it rot away. So not ideal hay storage in this picture. I think what's important to understand is that with a round bale, if we look at just the outer 4 inches of that round bale, we're losing about 1/4 to 1/3 of that bale, depending on the size. So the smaller the bale gets, the higher the losses will be as a percentage of that total bale. So when you look at a round bale that's been stored outside, and you say, well, I only got 4 inches of loss on the outside, that can constitute 1/4 of that total dry matter in that bale. And this is just a chart that kind of shows that. And if we look at a weathered layer of 6 inches on a 5-inch bale, that's 1/3 of that total bale, 36% of that total bale. So that surface area makes up a larger total proportion of that bale volume versus the inner center of that bale. And that's important to understand. So if we look at storing storing hay on a rock pad outside, we had a 10% dry matter loss in the study that was conducted here at the University of Kentucky by Mike Collins and colleagues. Compared to storing it directly on the ground, we had a 30% dry matter loss. Why is that? The reason why is that we think that a lot of the spoilage comes from rain from above, but really the majority of spoilage comes from that bale wicking moisture up from the ground. When we put it on a rock pad, we break that ground contact and we get less dry matter losses. So if we can break that ground contact, we're going to really improve hay storage, even if it's just outside. In this picture on the top, we see hay stored along a tree line, commonly done, not ideal, because we're shading, that hay is shaded on one side for a considerable amount of the day. It never allows it to dry out. We don't want to store it in tree lines, ideally, where it can't dry out. Ideally, we would store it in long rows going down a gentle slope. And we want 3 to 4 feet between those rows. That allows water to shed off of that bale and then run down that slope. This is not the ideal situation. There should really be 3 to 4 feet between these bales, and these bales should be placed end to end going down the slope. Right now, there's nowhere for that water to run. It's going to kind of pond between those two bales and cause more damage to those bales. Net wrap on the ground, we lost 23% dry matter compared to 30% for twine on the ground. So net wrap does shed some water, and it kind of holds the bale together when we left it up. But the difference in dry matter loss was not as much as you would expect. If we used black plastic to wrap that bale with versus net wrap, we only had 5% losses. So that's black plastic's doing two things. It's shedding water off of that bale, and it's breaking ground contact, allowing that bale to wick less moisture up. And this is very comparable to storing that bale in a conventional shed. And if we're stacking bales, it's absolutely imperative that we cover them with a tarp. This is a terrible situation if we just stack them and leave them out, because water gets ponded in there and kind of runs down in here and can't go anywhere. And that causes a lot of dry matter loss when they're stacked without a tarp. The ideal situation is that we put them under roof if we possibly can. And that really reduces dry matter losses and preserves hay quality. Hay that's stored off the ground under a roof can last for a long time without losing significant hay quality. And that's very important to remember. I want to finish up tonight and just talk a little bit about the dollars and cents of making hay. And I think it's always important to think about the costs associated with making hay. And we can kind of divide those costs up into two, fixed and variable costs. And the primary fixed cost would be machinery, and we call those fixed or sunk costs. So when I buy a piece of machinery, I've got to pay for it whether I make hay or not, and it's going to depreciate. So that's a fixed cost. And as we tend to use that piece of equipment more, we tend to decrease our fixed cost per unit of hay preserved. If I make 5 bales of hay, the fixed cost is going to be much higher because I need to spread that machinery cost out over those 5 bales of hay. It's going to be much lower if I make 500 or 1,000 bales of hay and I spread that fixed cost of that machinery out over those 500 or 1,000 bales. And I've got a diagram to show that in a minute. Variable costs are kind of what we call our out-of-pocket costs. They include things like twine and fuel and labor. So that's going to be a cost that's going to be the same for the first bale or the last bale. As I tend to produce more bales, the total variable cost will tend to increase. But the cost per unit will stay the same. So this is the machinery investment. And you can argue about this, whether you buy new equipment or used equipment, or whether you can get a better deal on the tractor than I can. It doesn't really matter. This is just an illustration. And what I want to point out is that the total investment cost, even for used machinery, is substantial. And we need to think about that investment cost in the terms of cows. Remember, a cow in a cow-calf operation produces a saleable product. A hay baler in a cow-calf operation does not produce a saleable product because we're not selling hay. We're feeding that hay through the animal. So it's got to make the profitability in order better for that cow-calf operation to own that equipment. All right, so this is just a nice diagram of the impact of making more hay has on fixed costs or machinery costs. So we can have if we make just a little bit of acres, so 25 acres, we have a very high per unit machinery cost. As we start to make more acres of hay, that machinery cost per ton of hay decreases significantly. This pink line is the variable cost, and that variable cost stays the same. So it costs the same amount in fuel and twine to make the first bale as it does the last bale. but the machinery cost decreases significantly. Why am I showing you this? I'm showing you this because if you're a small producer that's got 40 cows, owning a full complement of hay equipment may not be the best investment economically for your operation. So you'll have to think about that. So when should you own equipment? Own if the total cost of making that hay, fixed plus variable costs, are greater than, so you own it if that's less than what it costs to purchase hay. And then you need to figure in your risk factor and your hassle factor going out and trying to find decent quality hay. And then subtract out added animal capacity. So if I'm not making hay, could I add more animals to my operation? Sometimes the answer is yes, and sometimes it's no, depending on where your hay fields are located at. Own if hay purchase or custom harvest options are limited in your area. So if you can't buy hay or you can't get somebody to cut hay for you, then you might have to own equipment. Own if that equipment's part of a viable custom harvesting business. So if you're cutting hay for your neighbors, then you have a viable custom hay operation, and it may justify the cost of owning that equipment. Own if it's part of your grazing management. So if your grazing management requires that you cut hay at certain times of the year, then it may be a good investment. I can think of other ways to manage that excess growth that we're not going to talk about tonight during certain parts of the year, other than owning a full complement of hay equipment. But that's something you have to take into consideration for your individual operation. So kind of to summarize this particular topic, it's important the cost of owning machinery, and then ask yourself, is there things that I can do that's an alternative to owning that machinery? Can I improve my grazing management? Can I stockpile for winter grazing? Can I buy hay instead of making my own hay? Having cash flow to pay for machinery doesn't necessarily make it a profitable investment. And that's something that each individual operation is going to have to assess. But just because you have the cash flow to write the check for that machinery doesn't always make it a good investment. Owning equipment isn't a bad thing. And I don't want you to take that away from this presentation, but it's got to improve your bottom line. And the only one that can tell if it's going to improve your bottom line is going to be you, because you're the one with the pencil and the calculator, and you've got to do those calculations to figure that out. And then of course, you want to size your machinery for the amount of hay acreage you have so that you can harvest it efficiently to achieve lower costs. All right, this is just a rough budget for a mixed grass hay at 3 tons per acre. And you can argue with me on the cost of production here, but I think if you're honest and you go through and you look at all your costs, you're going to be in that $80 to $100 range for making a ton of hay. I've got 120 in this particular budget, and that's variable cost, lime, fertilizer, and so on, twine, diesel fuel, and what have you, and then machinery costs. So that cost of owning that baler and that mower and that hay rake and that baler and so forth. And together they come out to about $120 a ton, and it may be less for your particular situation. Even if you have used machinery, at some point you're going to have to replace that used machinery and or repair it, and that's important to factor into your hay production cost. And then I'll throw this at you. So this was, I got off of, I think, Facebook Marketplace, and it says clean 2020 tall fescue, net wrapped, rolled with a John Deere baler, good tight bales, 1,200 pounds. Well, I don't know if they're 1,200 until we weigh them. $25 each. So say they're not 1,200 pounds, say they're 1,000 pounds. Well, I do the math on this. If 2 bales make a ton of hay, I'm paying $50 for a ton of hay. If it costs me $120 to make my own hay, or even say it costs me $80 to make my own hay, this may be a pretty good buy. Now, The other thing to take into consideration is when I buy hay, I'm also buying nutrients in. So every ton of hay is going to have 15 pounds of phosphate in it, so phosphorus fertilizer, and 40 to 60 pounds of potash in it, and 40 to 60 pounds of nitrogen, plus micronutrients and organic matter. And you're bringing those nutrients into your grazing system when you purchase hay and feed that hay effectively on pastures. So when I say feed it effectively, I mean we're moving that hay feeding points around my pasture, unrolling that hay, or somehow getting those nutrients more uniformly distributed throughout my pasture area. The downside of buying hay is that it can be lower in quality. So we've got to make sure that we're getting good quality hay, and we've got to make sure that we're not bringing a bunch of weed seed in with that hay, which can be a real problem. And I'm going to end here and just with the photograph to remind everyone that the good Lord gave us some really efficient forage harvesters. And, you know, as cow-calf producers, we really need to think about what can I do to allow these guys to harvest forage for themselves more days of the year. That should really be our ultimate goal. If you're interested in extending your grazing season, we had a great conference not this last winter, but the winter before, on optimizing winter grazing in transition zone states like Kentucky. And you can find those videos on our KY Forages YouTube channel. If you're interested in looking at those, just search KY Forages YouTube, and it'll be the first or second thing that pops up. All right, with that, I'm going to go ahead and end my presentation, stop sharing my screen, and I'll take some questions.
Okay, if you all have any questions, feel free to put them in the chat. All right, Doc, I got a 3-part question. If hay is pulling moisture from the ground with rocks as the base outside, is it still doing it so in the barn with the rock floor? Second part of the question, you want to answer that part first, and then I'll get you the rest of it.
So the diagram that I showed was that having that rock base outside, and those would be ballast size, or I call them railroad size rocks. They're breaking ground contact, so it's greatly decreasing the amount of moisture it's pulling up outside. But I would say even in a barn, you're still going to be wicking some moisture up into that bottom layer of hay stored in the barn.
All right, part 2. What's the best floor to have in a barn?
So I would say the ideal floor would be, and I'm not an ag engineer, so I'll qualify that before I even say this, but I think some kind of a large aggregate, so like a railroad size rock, would help to break contact. The ideal floor, of course, would be a wood floor that would elevate the bales off of the ground, but that's not practical. So I would say like a railroad size ballast to break ground contact would be ideal.
All right, and the last part here. Storing hay under roof, does stacking it on the end versus the side make any difference? Is it better than the regular pyramid side or pyramid method?
That's a great question, and I'll qualify by saying I've never seen any data on the orientation of stacking in a barn, so I don't know for sure. I would say it's probably going to make a minimal impact, but I don't know for sure.
Okay. Kevin asked, would the same information apply for equine? Kevin, I'm not sure what information you're referring to. Doc, if you got an idea, fire on it.
So I would say that generally speaking, the same information would apply. We usually think of equine quality hay as being harvested at the correct dry matter so that we have no molding. Horses, for whatever reason, tend to be more sensitive to respiratory issues associated with molding in hay and respiring those mold spores into their system. So we certainly want to make hay that's good quality. A pleasure horse is going to need somewhere around 60% total digestible nutrients, and crude protein of around 10% to meet their nutritional requirements. Now, as we move into horses that are more athletic, whether we're hunters and jumpers or reining horses or hunter pleasure horses, they're going to have a higher nutritional requirement. It may be hard to meet their nutritional requirements with just hay.
Okay, you did good. Uh, Ryan asked, "What's your thought on spraying hay fields for weeds?" And I'm assuming from a quality standpoint. Ryan, if you missed last Monday's presentation, contact your county agent, and they have access to the recording. And Dr. JD Green did a great job of deep diving into weed control options.
So I would say we definitely want to control weeds in hayfields. And over time, as hayfields thin out, you know, the good Lord doesn't leave bare spots in hayfields or pastures. He fills them in with something. And a lot of times those are weeds that tend to be less palatable, can be toxic at times. And if we have toxic weeds in hay, it's harder for animals to sort those out as they eat that hay when they're dried and rolled up in the hay bale. So I would tend to want to control problem weeds. The other issue with having a lot of weeds in pastures is that we're going to lower yield of that pasture. Quality may be similar in some cases because weeds can be fairly high in forage quality, but their productivity tends to be lower. And so if I've got a weed taking up a space where I could have a more productive grass plant, that's going to lower overall production from that field. And I will say, and I know JD did a great job last week, but really when we look at weed control in hayfields and pastures, it's got to be an integrated approach. So we've got to make sure that we're growing adapted forages, that we're growing them in the right spot. We can't grow alfalfa on a poorly drained soil, that we're fertilizing them correctly. That's absolutely critical so that we get a dense and vigorous sod that's going to exclude weed growth. And that we have good grazing management and good mowing management of hay. If one of the worst things that's happened to hay stands in Kentucky and other transition zone states, especially orchard grass, is the invention of the disc mower. Disc mowers can mow so close to the soil surface that that close defoliation will actually hurt grass stands in hayfields and pastures.
Thank you, sir. Hey, Billy, if you don't care to type your name in the chat box so we can make sure you get credit, I greatly appreciate that. Next question, Doc. What fertilizer is most commonly recommended for hay fields in eastern Kentucky where sold quantity isn't as good as central Kentucky, where soil quality isn't as good as central Kentucky?
Okay, so we didn't talk about a lot about fertility in this presentation, but soil fertility is absolutely critical for both hayfields and pastures. And that the right amount of fertilizers is probably not going to be a triple 19, which most people like to put on hayfields. When hay is grown, it's going to remove a ratio of nutrients that's approximately 3 parts nitrogen, 1 part phosphate, and 3 parts potash. So we want to mimic that removal. So a 3-1-3 ratio would be ideal. And we want to base our whole soil fertility program on a soil test. And your local agent can help you get that soil test. And if we're behind in potash, which commonly happens, especially if we're using triple 19, we need to add that extra potash to bring that productivity up. So the answer is get a soil test, make sure your pH is where it needs to be, and make sure that your phosphorus and your potassium are where they need to be. So we've got to have a balanced approach to that soil fertility in pastures.
All right, next question. Gentleman has a friend in northern Indiana that sprays molasses at 2 quarts in a 5 gallons of water the evening before he mows. Any words of wisdom on something like that?
I've never seen any data on that, so I can't really say that it does or doesn't work. I'm just saying I have never seen any data on that, and I'm not sure that 5 gallons of molasses over 43,000 square feet would make that much of an impact, to be quite honest with you.
Well, that's going to wrap our questions up. Guys, if you got any more, feel free to put them in the chat. Dr. Teutsch, appreciate you taking your time this evening for talking with us. And it was District 1, not Buffalo Trace. Sorry, there's a few more counties than the Buffalo Trace counties. Next week will be the same time. It's going to be February 22nd, and we're going to have Dr. Ray Smith with us, and he's going to be addressing warm and cool season forages. And I don't see any more questions, so everybody be safe tonight. I think they're calling for a little snow, so safe travels if you're going anywhere. This will be recorded. If you would like a copy, feel free to get a hold of your county agent, and they will have it by tomorrow afternoon. Also, I sent out the survey link for the Master Haymaker sign. Please take time to fill those out. You have to attend all 7 classes to get the sign, to get credit for it. If you missed one, no problem. We like I said, it's recorded. We can make it up. No big deal. Just let me know, and I can get you the information you need. April, Tad, do y'all have anything you need to add?
I don't. I will update the attendance list from this evening. I'll have Philip go ahead and include that in one of the future emails just to confirm, to make sure I didn't miss anybody, because I am human and it can happen. But as of right now, thank you all so much for being consistent and attending all the sessions. They're all great, and we greatly appreciate the specialist.
Thank you for having me. Have a good evening.
Thank you, sir. Hey, Keith, if you don't care to send me an email afterwards, the information you're requesting is a little bit too big to get in an email. So send me an email and I will see if I can get that information to you, sir. Well, ladies and gentlemen, everybody have a wonderful evening.